Exercise 1106, past HSC exam from 2011, question 27C. Two brands of light bulbs are being compared. For each brand, the life of the light bulbs is normally distributed, which means we can use our three percentages of 68, 95 and 99.7. Normally distributed, we can use those three percentages, which are 68%, 95% and 99.7%. One of the brand B light bulbs has a life of 400 hours. What is the Z-score of the life of this light bulb? So brand B, what's the mean? You can look at the table. The mean X bar is 500 and standard deviation S is 50. Look, I can draw my little graph for brand B if I want, or I can use the formula. So brand B, we've got 500, standard deviation is 50. So what's my next thing up? 550, remember this? 600, 650, their Z scores 1, 2, 3. Then I can come down 450, 400, and 350. Look, if you want, you can use the formula. You can use the formula. It's worth 1 mark. But I can already see what the Z-score is. Can you see the Z-score for 400? It's -2. So if I want that, I can use the formula. Z-score is X minus X bar, or the mean, over standard deviation. So it's 400 minus 500 over the standard deviation of 50. So that's -100 over 50 is -2, which is what we got by just looking at the graph. Okay? Now, part B, or part 2. A light bulb is considered defective if it lasts less than 400 hours. The following claim is made. Brand A light bulbs are more likely to be defective than brand B light bulbs. Is the claim correct? Justify your answer with reference to Z-scores or standard deviations or the normal distribution. So we know that this is brand B's distribution, like, you know, like scale sort of thing. I can do brand A scale if I want, or I can just start working out Z-scores. I'm just going to do the brand A scale. The mean is 450, but the standard deviation is 25. So let's go down first to the negative Z-scores. What's -1? Sorry, I should have put those underneath. So what's -1's quantity? Hours. Guys, standard deviation is, the standard deviation for this one. So brand A, the standard deviation is 25. So we've got 425, 400, and 375. You can already see that Z-score -2 for both brands is the same. It's 400 hours. Can you see that just by looking at the graphs? I mean, the other thing I could have done was work out the Z-score for brand A at 400 as well. So 400 is the magic figure because the statement says a light bulb is considered defective if it lasts less than 400 hours. So we can do the Z-score for brand A, but, so I'm going to go ZB, ZA. Z-score for brand A for 400 is 400 minus 450 over 25, which is also -2. So 400 represents a Z-score of -2 for both light bulbs, which means, so I don't have to go up here and do these other numbers, all right? So what do you think about the statement? Bright A light bulbs are more likely to be defective. No, they're not. So is the claim correct? We'll say no, the claim's not correct. They are equally likely to be defective because you might say that 400 hours represents a Z-score of what? Z-score of -2 for both brands, for brands A and B, for brand A and B. So therefore, they are equally likely. Well, no, they're both the same. In terms of defectiveness, you'd say one is not more likely to be defective than the other. The percentage, and we could also, if we wanted, work out the percentage that would be likely to be defective.
How do we do that?
Well, you'd have to look at the percentage from down there, would give you the percentage likely to be defective is the same for both, because defective is from the arrow down. All right, so if defective is the highlighted bit, isn't it? The percentage defective is the highlighted bit on my graphs. Anything less than 400 hours. Those two percentages are the same because they're from Z-score -2 and down. So the reason is the percentage defective for both brands is the same. Percentage defective for both brands is the same. Now, I don't think you need to work out that percentage, but we could if we wanted. Do you remember how you do it? When it's from one section down to the end, it's always, you always got to look at the 50% minus. So if you want to work out that bit down there, we know that all the way down there is 50%. So it's 50% minus that bit. Do you remember? If you want to do this arrow down, it's all the way down from halfway, take away that bit. That's how you would get it. So the percentage defective is actually 50% minus, do you know what percentage from -2 to 2? What's that number? No, 95%. The three numbers are 68%, 95%. So this bit here, half of that is 47.5%. Halfway down is 50%. So the percentage defective for both brands will be 50% minus 47.5%, which is 2.5%. So both brands have the same percentage that will be defective. Worth 2 marks. It would be 1 mark to say that the Z-score for both is -2, and 1 mark to then either say whether he's correct or incorrect with justification. Not to say no, that's not good enough. You need to say no, it's incorrect because they're both equally, they both have the same percentage that would be defective. I don't think you'd need to work out the 2.5%, but you could show it on the graph or something that it's from Z-score -2 down. That's the percentage that are defective for both brands, so it's the same. All right? Okay, next question, 2016 HSC. Question 30D. Now, this is an unusual one. There hasn't been a question like this before because you have to use Z-scores and solve simultaneous equations as well. So you've got to come up with 2 equations. Now, it says the formula to calculate Z-scores can be rearranged to give the mean equals the score minus the standard deviation times the Z-score. So that's just the Z-score formula rearranged, okay? They're not asking you to rearrange it. They've given you the rearranged formula. Now, in part 1, it says, in an examination, Aaron achieved a score of 88, which corresponds to a Z-score of 2.4. Substitute these values into the rearranged formula above to form an equation. Now, that bit's not hard. So we've got x bar equals x minus sz. Aaron achieved a score of 88. So that's what x is, and the Z-score for him was 2.4. So we can substitute x is 88, not x bar, that's the mean or the average for the class. So x bar equals 88 minus s times 2.4, which is 2.4s. S times 2.4, in other words, it's x bar equals 88 minus 2.4s. That's part 1, that's your first equation. Part 2 says, in the same exam, Brooke achieved a score of 52, so she's got a score of 52, which corresponds to a Z-score of -1. So we put that into the equation as well, into the original equation. So we've got x bar equals x minus sz. We don't know what x bar is. The score is 52. Take away s times, be careful here, -1.2. So x bar equals 52. Now it's going to be take away -1.2s, which is going to be what? So it's take away -1.2s, which is x bar equals 52 plus 1.2s. Now I have 2 equations. Equation 1 and equation 2. Now we've written that second equation. The next bit is, so that would be worth 1 mark. This would be worth 1 mark. The next part says solve these equations simultaneously to find the value of x bar and s. Now, the x bars are the same. Do you remember how to solve simultaneously? You do one equation minus the other if something in those 2 equations is identical. Now, If I do equation 1 take away equation 2, and I will do that because the coefficient of the x bar is the same. So x bar minus x bar is 0. That symbol minus itself is 0. Or that, it's like x minus x is 0. X bar, mean, take away mean. Do you want me to, let me put that equation underneath it. Do you want me to rewrite them? What I'm just doing is this equation, take away this one. X bar minus x bar is 0. Then I do the numbers. 88 minus 52 is, someone, 36. Negative 2.4 take away 1.2. Negative 2.4 take away 1.2. Use your calculator. Negative 3.6. Now, why don't I take this minus 3.6s to the other side? So 3.6s equals 36. I can already see that s is 0.1. And now we divide by 3.6. So s is 36 divided by 3.6, which is, sorry, 10. Sorry, it's not 0.1, it's 10. 10. Next, remember, now that we know what s is, we can substitute it into either equation. I'm going to put it into equation 2. So sub s is 10 into equation 2. We did simultaneous equations, I believe, in year 12, I think. Last year. It was last year, at the end of last year. All right? So x bar equals 52 plus 1.2 times. So I'm putting s is 10 into this. X bar equals 52 plus 1.2 times 10. So it's 52 plus 12, which is 64. And we're done. So in other words, the mean of this test was 64 and the standard deviation was 10. Let's see if that actually makes sense. Now, you don't have to do this, but I'm just going to show you. If the mean's 64, standard deviation's 10, haven't I got 64, 74, 84, etc., right? And haven't I got 54, 44? And let's see if it makes sense. Look who got what. I know I can do 3. I'm not going to do 3. Oh, no, I will do 3 because the first person got a z-score of 2.4. And negative 3 is 34. All right, here we go. Let's see if the whole question makes sense. It says that Aaron got 88, which is about here, and got a z-score of 2.4. Does that seem feasible? Very feasible. It's not exactly halfway between, but it looks about right. And it says that Brock got 52, which is down here, and got a z-score of negative 1.2. That looks about right too, because it's between negative 1 and negative 2. So that all makes a lot of sense. Okay? Does it make sense now? All right, so HSC, question 28A. The graph indicates z-scores of height for girls aged 5 to 19. See, 5 to 19, their age versus their height. You may have seen the little blue books with the growth charts. Right? So, it says here basically an 8-year-old. Oh, these are the z-scores. So, the 0 here is the average height. So here we go. Look at this. How you girls are 17, 18? If you're 18, the average height, the z-score, the average height of an 18-year-old is 100 and, to me it looks like about 163 centimeters. Now, the standard deviation would be this distance. Oh, I like this question. And the standard deviation would be that, and that's a standard deviation, and that's a standard deviation. Because look, girls, you can see the numbers here on the side. We've got mean, z-score 1, 2, 3, mean z-score, this would be -1, -2, -3, because the values are going down. All right, now, oh, I like this question. So it says, what is the z-score for a 6-year-old girl of height 120 centimeters? So we want a 6-year-old girl that is a height 120. So we come to 6-year-old, where is the height of 120? Here we go, here's 120, it's there. Now we follow the line, and what's the z-score? No, Guys, this, oh, sorry, I'm sorry. I've gone to the wrong bit. 6-year-old 120, sorry, is there. What's wrong with me? It's the Z-score is 1. I'm sorry about that. I've got to get, yeah. Okay. Because I just read off 6 and 120. Look, 6 and 120 is on this line. We follow the line and we get 1. So you have to do, it's like the X and Y bit, and then you go along the graph to read the Z-score. We want 6-year-old 120 centimetres, come across to 6, go across at 120, put a dot, and then follow the graph. And what have we got? A Z-score of 1. Next part of the question. So 1, the Z-score is 1. Next question, Rachel is 10.5 years of age. Now it says if 2.5% of girls of the same age are taller than Rachel, how tall is she? Now we've got to work out what this 2.5% is. Now, it's that last bit. Yes, it is. I'm going to just draw a little thing here. So before we can do part 2, let's see what the 2.5% is. I've got Z-score 0, 1, 2, 3. Z-score -1, -2, -3. Remember the 3 values that they give you are 68%, remember? 95%. Now, let's just stop here at 95% for a minute. If it's 95% from -2 to +2, then the leftover bits on the end add up to what percent? So if it's 95% from -2 to +2, these other highlighted bits have to add up to 5%. It's a normal symmetrical distribution. So if I want to share these two between 5%, they're 2.5% each. Now, that's where the 2.5% is coming from. So let's go back to the question again. All right? You notice in the last question we did that 2.5% came up, but it was down at the bottom end. The 2.5% was down here. Z-score -2 down was 2.5%. Let's look at the question again and read it carefully. Rachel is 10.5 years of age. If 2.5% of girls of the same age are taller than Rachel, how tall is she? So we know that this Rachel has a Z-score of what? What is Rachel's Z-score? If 2.5% of girls are taller than Rachel,
2.
Rachel has a Z-score of 2. Now this is only worth 1 mark, okay? So let's go up and see how tall she is. So, how old is she? 10.5. We need to look up at 10.5. And we need to go to Z-score 2. That's Z-score 2, right? And we need to read how tall she is. How tall is she? 155 centimeters. So Z-score 2 is this whole line there. So, how tall is Rachel? 155 centimeters. So, Rachel is 155 centimeters tall. She's got a Z-score. Well, that's because only 2.5% of the population are taller than her. Of course she's tall. She's not like the average kid. The average 10.5-year-old, let's have a look. Z-score 3210. The average 10.5-year-old is just over 140 centimeters, 143. Question part 2 says, Rachel does not grow any taller. At 15.5, what percentage of girls of the same age will be taller than Rachel? Well, it's saying that Rachel does not get any taller. So, if Rachel does not get any taller, I have to keep her at 155 up to the age of 15.5. So, Rachel does not get any taller. At 15.5, she is the same age. She now has a Z-score of -1. So, I need to have a Z-score of -1 for her. So, Rachel at 15.5 is still 155 centimeters tall, which represents a Z-score of -1. Now, looking at our graph, it says what percentage of girls are taller than her now. Now we've got the 68% here. If I've got 68% from there to there, what percentage lies on either side? If I've got 68% of girls between -1 and 1, what's 100 take away 68? 32, and I have to spread it evenly between the left hand and the right hand side. That's 16% on each side. So the answer to that question, what percentage of girls of the same age will be taller than Rachel? So 16% of the girls will be taller than Rachel.
Wait, why?
Because, oh, sorry, I've got that wrong. It was -1. I'm sorry. So it's 16 plus, sorry about that. So it's this bit. It's the 16% plus the 68. So the percentage of girls taller than her will be that. Well, it's basically 100% minus 16.
84.
Or 68 plus 16. So I can do it as 68 plus 16, which is 84%, or I could have done 100% minus 16 is 84% of the girls. So if she's got a Z-score of -1, this is, I can do this two ways. I can say that bit is 50%, and this bit, if I want, is 34. So I can do it like that too. Or I could have done 50 plus 34 is 84%. So I could have worked it out 3 different ways. And the last question is, what is the average height of an 18-year-old girl? So looking up the 18-year-old girl, Z-score 0. And there it is, coming across. Look, it looks about 163 to 164. So it's a bit hard to tell. I think it's closer to 163. So last part, the 18-year-old girl is approximately 163 centimeters. Okay? 18, that's year-old girl, is 163 centimeters. Okay, so